The heat pump is located outside the property. The manufacturer's guidance to clearances around the unit should be adhered to allow optimum performance and service maintenance requirements. The available heat in the outside air is drawn across the heat exchanger at the rear of the unit, which is called the evaporator, by the integral heat pump fan. Even at lower temperatures, the heat in the outside air is warm enough for the refrigerant liquid in the heat exchanger to evaporate and turn into a refrigerant gas. The design of the evaporator allows the liquid to gas change to occur in several areas of the heat exchanger to maximise efficiency. The four-way valve allows the unit to switch over from heating to cooling mode if required, and to aid in defrosting the fins. The refrigerant gas is then directed through a scroll or rotary compressor, which increases the pressure, causing the temperature of the refrigerant gas to rise. A scroll compressor is shown here. The current Bosch heat pump uses a rotary compressor, but both have the same function. The refrigerant gas, which has now been heated, is passed through another heat exchanger called the condenser. As the heat is transferred from the condensing heat exchanger into the system, the gas falls in temperature, releases its latent heat, and then returns to a liquid state. The heated water on the central heating system side of the condenser can then be transferred into the heating or hot water system. The high pressure liquid is then drawn across the expansion valves to return to the start of the cycle and be in low pressure, low temperature state. The liquid receiver retains any liquid refrigerant to prevent any liquid being drawn into the compressor. The heat pump can operate in a very efficient manner when used in a heating system. Lower temperature systems such as underfloor heating will be a real benefit when connected to a heat pump, as in general this will increase the coefficient of performance.